Hello guys, my name is Joseph Lyle H. Solis, and today we're going to talk about the molecular structure of sulfite. And to start, we have the given formula for sulfite, which is SO3 and negative 2. So, first thing we need to do is find the number of shared electrons, and to do that we have the given formula as S equals N minus A, where S stands for the shared electrons and N stands for the maximum capacity of that atom, and A is the available electrons in that atom. So 8 times 4, since sulfur and oxygen has the same capacity, and minus 6 times 4 plus 2, since 6, they are both in group 6 and there's a reduction of negative 2, so 32 minus 26, we have 6 number of shared electrons, which is equivalent to 3 bonds. So there you have it. We have 6 shared electrons and 3 bonds for sulfite. And next thing we need to do is finding the structure, drawing it, I mean. So to draw a structure, we need to first find the central atom. And to find the central atom, we need to look at the electronegativity of those atoms, and which comes the least is the central atom. So looking at the table, we can see that sulfur is less than oxygen, therefore we use sulfur as the central atom. Now drawing the structure, we have sulfur, oxygen, 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 then the dots, which is the electrons. Sulfur has this number of 6 electrons, so we have 1, 2, 3, 4. So same goes through with oxygen. So since we have a reduction process, we have 2 here like that. Then we can move these 2 electrons here. So let's move it. So let's erase this. Then let's draw it there, because if I move it there, these 2 will have a formal charge of -1, then this 0, then here is 0 for sulfur, so it satisfied the compound there. And now let's determine the number of electron groups. In determining the electron groups, we consider 2 things: the number of bonds, then the number of lone pairs. The bonds is still considered as one electron group, even if it's a double bond or triple bond. Now let's do it. Here's one double bond, one single bond, another single bond, and a lone pair. So therefore we have 4 electron groups. Then since we have 4 electron groups, we can say that this compound has a tetrahedral electronic geometry. So next thing we need to do is the molecular geometry. Since it has one lone pair, it's called a trigonal pyramidal. Sorry for that. Trigonal pyramidal. And lastly, we're going to find hybridized form of the orbital, so of sulfur. So we have the electron configuration for that, which is for sulfur neon 3s2 3p4. So neon 3s2 3p4. So the hybridized form is, we were going to use the sp3 orbital because it's a tetrahedral. 3p3, sp3, I mean 1 for s, 3 for p. So since he has 6 electrons, we have 1, 2, 3, 4. We have 2 left electrons, so we're going to draw 2 lines for 3p orbital, which will occupy 2 electrons. So I forgot this. We need to put still the neon for the electron configuration for the hybridize. Sorry for that. Then it's done. Thanks for watching, guys. I hope you enjoyed it. See you next time.